Somewhere in the shallows of this muddy coastal riverbank, a 2,000-pound apex predator is hiding in just 30 centimeters of water. To the naked eye, the surface looks completely empty. A wallaby approaches the edge for a drink, completely unaware of the threat resting a few feet away. If we freeze time right before the strike, we can look at the physical condition of the predator below the surface. This specific crocodile has not consumed a single meal in over 12 months. As an ectotherm, it draws its body heat directly from the sun and the surrounding environment. Because it does not burn calories internally to maintain its body temperature, its daily energy requirements drop to a tiny fraction of what a mammal of the same size would need. 66 million years ago, an asteroid impact triggered a global winter and collapsed the food chain, starving the warm-blooded dinosaurs to death. The crocodilian lineage survived by simply powering down and waiting the disaster out. Brute strength is useful, but extreme energy conservation is the trait that guarantees survival across deep geological time. While waiting in the dark, the crocodile isn't operating blind. The scales across its snout and body are covered in microscopic organs called dome pressure sensors. These organs act as a highly sensitive grid, detecting tiny changes in water pressure, temperature, and salinity. They generate a detailed, three-dimensional physical map of the water, allowing the animal to lock onto prey without relying on its eyes or ears. Beneath the armor, the internal physiology is almost entirely shut down. The resting heart rate drops to as low as 2 or 3 beats per minute. This animation shows a unique crocodilian heart valve known as the foramen of Panizza. When submerged, the lungs have no fresh oxygen to process. So this valve shuts, actively bypassing the pulmonary system and recycling oxygen-depleted blood straight back to the brain and vital organs. This internal bypass stretches the remaining oxygen supply to its absolute limit, allowing the crocodile to rest completely submerged at the bottom of the river for up to 2 hours without taking a breath. Through structural anatomy and chemical regulation, the animal functions as a biological submarine, executing a flawless waiting game. Unpausing time, the strike happens in an instant. The crocodile uses its massive tail to propel its entire body length out of the water in just half a second. The jaws clamp onto the prey's limbs, securing a grip before the predator immediately throws its weight into a rapid twisting spin, the death roll, designed to disorient the animal and drag it into deep water to drown. In 2012, paleobiologist Gregory Erickson conducted a comprehensive study testing the bite forces of all 23 living crocodilian species to locate the strongest bite on Earth. The results confirmed that a standard 15-foot saltwater crocodile clamps down with a force of 3,700 pounds per square inch, or 16,000 newtons. That is the equivalent of a small car falling from the sky and slamming shut on a target. Because bite force scales directly with body mass, the numbers climb significantly higher for the largest animals. A massive 20-foot wild specimen is mathematically estimated to generate up to 8,000 pounds of pressure per square inch. The skull dedicates nearly all of its rear cranial space to dense, rigid closing muscles. But the muscles used to open the jaw are incredibly weak. So weak that a grown crocodile's mouth can be securely tied shut with a few layers of standard duct tape. The strike relies on an overwhelming, concentrated burst of mechanical force. It is designed to crush and drown in seconds, avoiding a long aerobic struggle that would quickly drain the animal's limited oxygen reserves. We often categorize reptiles as simple, instinct-driven creatures, but crocodilian neurology subverts that idea. They have a highly developed forebrain and are the only reptiles to possess a cerebral cortex. They possess an excellent spatial memory and use it for tactical planning. In areas where humans bathe or wash clothes in rivers, crocodiles will actively observe the patterns, memorizing the exact time and location to optimize their ambush. They have even been documented using tools. During breeding season, a crocodile will balance small sticks and leaves across its snout, lying perfectly still in the water to lure in birds looking for nesting materials. Strategic intelligence complements their mechanical power, creating an apex predator that is as cerebral as it is physically dominant. This combination of patience and intelligence provides an advantage in the river, Yet it doesn't account for how the species spread across the massive oceanic distances between India, Southeast Asia, and northern Australia. Looking at this map of satellite tracking data, we can see exactly how they navigate these marine barriers. The paths show individual crocodiles traveling hundreds of kilometers straight into the open ocean, far from any coastline. They practice a technique called ocean surfing. By riding seasonal tidal patterns, they can travel up to 590 kilometers with minimal effort. When the current turns against them, they simply float and wait for the tide to shift back in their favor. Surviving weeks at sea requires a specific physiological adaptation. Hidden beneath their tongues are specialized lingual salt glands that constantly extract and excrete excess sodium from the bloodstream, preventing dehydration in saltwater. Surfing these currents allowed the species to cross deep trenches and populate highly remote archipelagos, establishing populations in places as isolated as the Seychelles, thousands of miles from their origin. The crocodile's metabolic efficiency provides the stamina needed for global colonization, allowing a localized river predator to conquer entire archipelagos. The saltwater crocodile has undergone minimal evolutionary change since the dinosaur era. This design is so efficient at surviving environmental shifts that the species is considered 99.6% genetically perfect in its role as an apex predator. Human casualties in these territories often stem directly from complacency. The crocodile's hunting instinct is activated by perceived vulnerability. Turning your back or splashing at the water's edge signals an easy target, triggering an ambush. The rule of these waters is simple and absolute. If you are standing on the bank and you cannot see them, it means they are already watching you.